We're going to be talking about Chapter 4 this week, and that's dealing with numeration systems and some of the history of the numeration systems. We're going to talk about the Hindu-Arabic system, which is what we use in America. We're going to be talking about the Egyptian system, Babylonian system, so some of the different systems that you're familiar or that you might not be familiar with. This is actually sort of neat to think about how things evolved over the years and how things changed. So the first thing we're looking at today is section 4.1, which is dealing with some of the historical enumeration systems. So the basics of numeration, we're going to look at the ancient Egyptian, the Roman, and the Chinese numeration systems. So the various ways of symbolizing and working with numbers is called numeration. So, and then the symbols that we use are called the numerals. So in the Hindu-Arabic system, they use the numerals 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But before that had evolved, there were other systems. For example, the Roman numeral system, which uses X and V and I. And some of the other systems used other symbols that aren't as familiar. So those are just things, that's what we're talking about with the numeration systems. So one common way of counting things was to use the tally marks. And, sorry, not sure why that happens. It keeps happening. Is to use the tally marks that we're familiar with when you're tallying up something. So in this example, they have 8 tally marks, so they've got 8 things counted. So in that situation, if you want to think of it, we grouped by 5s. So our goal was to get groups of 5, and it helped to make things easier to count. Instead of counting every single tally mark, we just looked for those groups of 5, counted by 5s, and then added the extra tally marks in. So when we're talking about something like that, we're talking about a base. And the Hindu-Arabic system uses a base 10. So again, the first number is 10 to the 0 power, which is 1's place, and then 10's place, and then 100's place. In the tally mark system, we would be considered a base 5 because we're looking for groups of 5. So in the Egyptian numeration system, it is an example of a grouping system, and it's using 10 as its base 10. As its base. So here are some of the symbols that you should be somewhat familiar with. And again, don't panic when you see this. Remember that you can use your notes when you're taking the test. So just make sure that you have this very clear so that you can see these different symbols and what they stand for. So to represent the number 1, we just use a single stroke, which makes sense. To represent the number 10, we use what they call a heel bone. The number 100 is a scroll. The number 1,000 is a lotus flower. 10,000 is a pointing finger. 100,000 is the burbo fish. And a million, is an astonished person. So these are the different symbols that you will see for the Egyptian numeration system. So let's say I have this number that you see below. And again, to clarify, the number is this part of the problem. So remember, we're not dealing with 0, 1, 2, 3, 4, 5. And they want you to tell what does that number represent in the Hindu-Arabic system that we are familiar with. So we'll start with the burbo fish, and the burbo fish are 100,000 each. Then we have the lotus flowers. The lotus flowers are 1,000 each. Then we have the scroll, that's 100 each. Then we have the heel bone, and the heel bones are 10 each. And then we have the single tally marks, which are 1 each. So we have 2 burbo fish, so that's 200,000. We have 3 lotus flowers, so that's 3,000. 1 scroll for 100. 4 heel bones for 40. And 5 tally marks for 5. And then we add all those numbers together, and we will get 203,145. There we go. All right. So here we want to write the number 538 in Egyptian numerals. So we have to take each part of the problem. So we have 500 plus 30 plus 8. So then you have to remember that hundreds are, or 500 is 5 times 100. 30 is 3 times 10. So here we have 3 heel bones for the tens. We have 5 scrolls for the 100s, and we have 8, sorry, it didn't look like 8. And we have 8 tally marks for the 8 constants. And so the representation of 538 is what you'll see below. All right, now here is something that I've always thought was really interesting. Um, when you're multiplying 32 times 47 in the Egyptian, I'm sorry, in the Hindu Arabic system, we are familiar with multiplying 32 by 47. And for the most part, other than a calculator, most of us will go through this process where we will do 7 times 2 is 14. We carry the 1. 7 times 3 is 21, and the 2 is 22. 4 times 2 is 8. 4 times 3 is 12. And so those two numbers multiplied together is 1,504. So in the Egyptian system, this is what they do. They start with always the number 1. And then they take usually the larger number, the 47, and they write that next to the 1. And now we're going to double each of the numbers. 1 doubled is 2. 47 doubled is 94. 2 doubled is 4. 94 doubled is 188. Now our goal is to look at the left-hand column and try and get 32. Now I need to get 32 by either adding up a series of numbers or getting 32. So I keep going. 4 doubled is 8. 188 doubled is 376. 8 doubled is 16. 376 doubled is 752. 16 doubled is 32, and 752 doubled is 1,504. And so if you look at this, I now have the number 32, and it equals 1,504, which is the product of 32 and 47. Now this one didn't involve anything extra, but that's not usually the case. So let's look at a different example. Here we have 19 times 70. So again, we're going to do the same thing. Start always with 1. It doesn't matter what your two multiples are. We'll start with 1, and the first number is 70. Then we've got 2, and this is 140. Then we have 4. This is 280. 8, 560. 16, 1120. Now let's look for a second. If I take the number 16 plus 2 plus 1, I get 19. So 16 plus 2 plus 1 is 19. Well, now I'm going to take the numbers that correspond to those, and I'm going to put those together. So I'm going to take those three numbers, 11, 20, 140, and 70, and I get 1370. So now let's look at what we have here. 70 times 19. 9 times 0, 9 times 7 is 63. And then I have 0 and 7. And I have 0, 3. So the product of 70 and 19 is 1,330, and the Egyptian multiplication method, I got the same answer. So I've always thought that was really neat that they were able to do that and that it always works. No matter what numbers you have, you always start with 1 and double it and you will look for these numbers on the left to add up and get one of the multiplication numbers. So in the ancient Roman system, it modified it. It still uses 10 as its base, but it also has symbols for some of the other numbers such as 5, 50, and 500. They have a subtraction feature, and they have a little rule here. The smaller value to the left of the larger value indicates subtraction. And a really good example of that a lot of people are familiar with is the IV in Roman numerals represents the number 4. But V represents a 5, and and then the I represents a 1, so 5 minus 1 is 4. So let's look at some of the symbols. Okay, it also has a multiplication symbol. If you have a bar over a number, that means to multiply by 1,000, and a double bar over the number means to multiply by 100,000. I'm sorry, 1,000,000. So here are our symbols that we need to be familiar with. The I represents a 1, V represents 5, X represents 10, L is 50, C is 100, D is 500, and M is 1,000. So then if I wanted to create the number 6, I want to add 5 and 1 together. So 5 and 1, V and I would be 5 plus 1 since the I is on the right-hand side. So that's 6. 12 is the number 10 and 2 ones. So 10 plus 2 is 12. 19 is 10 plus 9. Well, the I to the left of the X means I take away, so subtract 1. So that gives you some ideas on what to do there. So if we wanted to take this symbol, this number, and translate it into the Hindu Arabic number system, we know M is 1,000. Since C is to the left of M and C is smaller, then we're going to take 100 and take it away from 1,000. XL is you're going to take the 10 away from 100 again since X is smaller than L. V is 5. The two I's are 1 and 1. So we have 1,000, 900, 40, 5, 1, and 1, which is 1,947. Okay, so what if I had the case here where I have again, Hindu Arabic, and I have the 26 minus 14. So 26 is the number XXVI. This is the number 26 in Roman numerals. And XIV is the number 14 in Roman numerals. So if I wanted to subtract those, it can get a little bit confusing because of the order. So we're going to change the lower, or the second part of this number to all ones. So we're going to have XX, and then we're going to have 6 I's. 14 is going to be X and 4 I's. Now I can just sort of cancel things out, and so I'm going to cancel these 4 I's with 4 of the I's up here, and I'm going to cancel the X with one of the X's, and so I'm left with X and 2 I's, which is 12. And if you do the Hindu Arabic math, 26 minus 14 is 12. All right, so another system we have is the Chinese number system. And the Chinese number system is a multiplicative excuse me, grouping system that always uses pairs of symbol. So what you're looking for excuse me, are pairs of symbols to group together, and one of them tells you what you're multiplying by, and one of them tells you what the number is. So we have, for example, the symbol for 1, the symbol for 2, the symbol for 3. Then we have the symbol for 4, 5, 6, 7, 8, 9. And the symbol for 10 is down here, over on the right-hand side. So for example, if I wanted the number 70, then I would put the symbol for 7 and the symbol for 10 together. So let's look at this. We're going to group in twos as much as we can. So when we group those two together, we have 7 and 1,000. So this is 7,000. Then we group the next two together, and we have 4 and 100, which is 400. We group the next two together, and we have 8 and 10, which is 80. And then, of course, you don't group that with anything because it's in the ones place, so that's 2. So this number comes out to be 7,482. On the second one, we group the first two together, and we end up with 2 and 100 is 200. The next symbol that you see here is 0. If you look at the chart, that's the number 0. And the last place that we have here is 1. So if we add those together, we get 201. We have to have that 0 symbol basically as a place marker to determine what the place, or to mark that 0 in the value. I hope this helps. I've really found chapter 4 to be very interesting. And especially if you're getting into any sort of computer science degree, you're going to have to use some of the number systems that are presented. Maybe not the Hindu Arabic and things like that, but some of the other number systems you will definitely be seeing. So it's something to think about as you're going through. So I hope you have a great week, and keep in touch with me about how your progress is going.